Okay, I saw this problem on the internet, and I do recommend you clicking this link over here, and it'll bring you to a YouTube video where I saw the problem. The way he did it's different than what I'm doing. I'm using Newton's method because this is in Newton's method section. And what they want you to do is they want you to maximize x to the y given that x plus y equals 8 and x and y are both non-negative numbers, real numbers. So over here, the way I did it, and I'll go through the steps for that, is we need to maximize a function. And the function is going to be a function of x. And that function is going to be x raised to the power, well, it's y, but what's y? Y is going to be equal to 8 minus x. That's why that's written down over there. I put the condition down that you have to be between 0 and 8 for the x. Right? So what I want to do is I want to visualize what it looks like. And I'm going to go to an application that allows me to graph things. So what I graphed out here, I graphed out, x, y equals x to the 8 minus x, and I also graphed out what appears to be a maximal point over here on it. I'm noticing that also I've restricted myself between 0 and 8. And looking at this curve over here, I do see a maximal value over here. And kind of looking at it, you're looking at 200 and something, certainly above 250. All right, now what's the x value around? It looks around, close to 4. All right, but anyway, let me go back to the reading of it. It says you may want to graph it, which I just did, and that's important. You look at the graph of it. The other thing I wanted to point out is that the maximum after I put the graph down is it appears to be somewhere around the number 4, certainly lower than 4, but somewhere around 4. The trick is here is to see that what you're actually trying to do is find out when the first derivative of that function f is actually 0. Let me tell you why that's the case, by the way. When you're looking at the graph, where does the maximum occur? When the horizontal tangent occurs. That means the slope of that curve is going to be negative there. And again, I'm looking at the picture. Right? So what do you do over here? And I'll go to the Sage math in a second. But I type things in. What do I type in? I first reset. I define a function. But the thing about this over here is really what I'm trying to do is I'm trying to solve the derivative for 0 of that function. So what I do is I decide a new function, which is a derivative of f, and then I use Newton's method. And I want to briefly go through that with you. So I'm going to launch Sage. I'm going to use a terminal to do that. Type in Sage. This is going to open up an instance of Sage here. It's version 10.2 at the time of doing this video over here. And it's running Python 3.11.1. So I'm going to just type in what I'm seeing. Reset. And then I type the f of x in. What's f of x equal to? It's equal to x, 8 minus x. Then I'm going to type another function, g. And what's g of x? It's the derivative of f with respect to x. Then what do? I'm going to type in a Newton's function. Now you notice when I do the notes, sometimes I do it one way, another way. I want to show you a variety of ways of doing it, by the way. So Newton's method, I'm just going to say it's n. N's a function of x. What is it? X minus, remember, we're trying to solve that function g for 0. This is typical Newton's method. What's going to be g of x divided by the derivative of g of x with respect to x. Now, by the way, these derivatives are not easy to take, but Sage has no trouble doing it. All right, no trouble whatsoever. All right, let me hit the return. Then the first thing I do is I get a seed value. And I'm going to use x to be 0. I'm sorry, x to be 4. And I can put 4.0 down. There's a reason for that. I want to use approximate numbers. And Sage actually believes I want an approximate now because they use a decimal point. And then what are you going to do? You're going to type in, that's my first guess, by the way. My next guess is going to be Newton's method, evaluated at x. But what I want to do is I want to display x. And you may wonder why I want to display x. I want to see if it changed. And it did change. It went from 4 to 3.357. And what I do is I do that again. I can hit the up arrow just to pull the prior command back and do it again. Now, by the way, it still changed, by the way. Now it's 3.5. It was 3.3 before. Let's do it again. And what do I see? 3.53. Well, you know what? It's getting better. It's getting closer, but still there are changes. It does appear to be changing. Let me hit the up arrow again. And what do I get there? Let's take a look at that over. It's still changed. All right, how do I know that? Looking at the end digits, actually. I'm not actually looking at every digit. Let's keep going. And right there, it changed again. I know that just by looking at the end digits. Let's do it again. Oh, it looks like it didn't change there. Let me just carefully look at it. 3.53, 540, 103. Yeah, it looks like every digit's matching up over here. This is within the precision of the machine. Now what do I want to do? I want to evaluate F at that number. What number are we talking about? That X number now. And that's going to be X. X is assigned that number. And let's hit return. And what do I get? I get 280.90. This is an approximate method, all right? So if you do watch the video, this guy has an exact method for doing it. It's something that's not being covered at Essex, but you may want to take a look at this and look at what he's doing and find it interesting, hopefully. And he's a good guy to watch, by the way. His name is, I'm not sure, can't remember his name, but, oh no, his name is Stephen Chow, I believe. But his YouTube name is Black Pen, Red Pen. And he does a great job. He really does. All right. So I also want to tell you that I want to, what's called an AI bot. And I've been finding these things quite interesting, by the way. And one thing they're quite good at responding to difficult questions with what appears to be incredibly intelligent language, by the way. And it certainly knows, it certainly knows a lot of mathematics, by the way. But if you read through it over here, you're going to say it really looks quite complicated about this. And at the end of it says that, you know, numerical methods or optimization software may be required to find an exact value of X and Y. But again, if you go back and watch this video up here, and I do recommend it, you're going to see Black Pen, Red Pen actually do the problem and get the exact value to it. But here, the deal with the exact value of it, it's a functional value, and it has to do with a Lambert function, a W function, and it still doesn't really tell you what the number is, right? It just like saying like, you know, almost like saying it's pi squared or something. It's not that elegant, by the way. It's a function. It's W something. And the bottom line is, this is why I went to a numerical technique, by the way. However, at the end of the video, this guy also resorts to using a numerical method to get these numbers over here. Does he get them as precise as I'm getting them? No. But the bottom line is, you've got a lot of options. Thank you.